All right, so in chemistry, we're always dealing with things that are just ridiculously, impossibly small. We're talking atoms, molecules, the very stuff our world is made of. So how on earth do we count them? How do you weigh something you can't even see? Well, today we're going to crack the code that makes it all possible.
I mean, it sounds kind of impossible, right? You can't just pop a single atom on a scale. So how do we bridge that gap between the tiny, invisible world of atoms and the world of grams that we can actually measure in a lab? That is the fundamental question we're going to solve today.
Well, the answer to this whole problem, it's a concept that's pretty much the secret handshake for all of chemistry, and it's called the mole.
Okay, so what is a mole, really? The easiest way to think about it is like a chemist's dozen. You know how a dozen is always 12, right? Doesn't matter if it's a dozen eggs or a dozen cars. Well, a mole is just a specific, way bigger number that we use to group atoms or molecules into a chunk we can actually work with. It's our magic converter between the invisible and the visible.
And this is the magic number right here. 6.023 times 10 to the 23rd. That is a 6 with 23 zeros after it. It's a mind-bogglingly huge number. It's called Avogadro's number, and it's the exact number of particles in 1 mole of, well, anything. Carbon atoms, water molecules, you name it. It's the absolute cornerstone that lets us scale things up.
Okay, so let's start building out our chemistry toolbox. The very first tool, and honestly the one you're going to use all the time, is the one that lets you go back and forth between the mass of a substance, something you can actually weigh, and the number of moles it contains. And here is the formula that makes it all work. The number of moles you have is just the mass in grams divided by the substance's molar mass. And molar mass, it's exactly what it sounds like. It's the mass of one single mole of that stuff, a number you can figure out for anything just by looking at the periodic table.
Let's just break this down into 3 super simple steps. You can't go wrong. First, you find the mass you're given in the problem. Second, you calculate the molar mass from the chemical formula. And third, you just divide that first number by the second. Easy as that.
All right, enough theory. Let's put this first tool to work with a real example. Let's say you've got 60 grams of carbon dioxide. The question is, how many moles of CO2 do you actually have?
Okay, let's just walk through our steps. Step 1, the mass is given right there, 60 grams. Done. Step 2, we figure out the molar mass of CO2. So we've got 1 carbon, which is about 12 grams per mole, and 2 oxygens, which are 16 each. Add them all up, and you get 44 grams per mole. And now, the final step. We take our mass, 60 grams, and we divide it by our molar mass, 44 grams per mole. And there it is, our answer. 60 grams of CO2 is the same as saying we have 1.364 moles. See? Just like that. Our first tool works like a charm. Okay, tool number 1 is in the bag. Let's grab the next one for our toolbox. We can get from mass to moles, but what if you want to know the actual number of individual atoms or molecules you're playing with? For that, we need the particle-mole converter. So this formula, it's the direct link between moles and the actual particle count. And it uses our old friend, Avogadro's number. If you know how many moles you have, you just multiply by that giant number, and it tells you exactly how many tiny little particles you're dealing with. Okay, let's try another one, but this time, let's mix it up. We're going to work backwards. Imagine you somehow know you have 8.9 times 10 to the 23rd individual hydrogen atoms. How many moles is that? So to figure this out, all we have to do is just flip that formula around a little bit. Instead of multiplying to find particles, we're going to divide to find moles. The number of moles is just the number of particles you have divided by Avogadro's number. Okay, now we just plug and chug. We take our 8.9 times 10 to the 23rd atoms, and we divide it by Avogadro's number. And what do we get? 1.48 moles of hydrogen. And boom, just like that, you've used your second tool to count a truly staggering number of atoms. Okay, so you've pretty much mastered the heavy lifting. Now, let's add a little bit of pro-level detail. The way we calculate the mass is exactly the same, but the word we use can actually change depending on the kind of compound we're looking at. This is the difference between molecular mass and formula mass. Here's the deal. It all comes down to structure. You're going to hear molecular mass when we're talking about covalent compounds, like water or CO2, because they exist as separate individual molecules. But we use formula mass for ionic compounds, like table salt, which form this big repeating crystal grid. The math is the same, but the words we use reflect what's actually going on with the chemistry. Let me show you what I mean. Take a look at these examples.
For something like benzene, which is covalent, we'd correctly say its molecular mass is 78. But for ionic compounds like aluminum chloride or iron oxide, we're technically calculating the formula mass. The way you get the number is identical, you're just adding up the parts. But, using the right term, that's what shows you really get what's going on under the hood.
All right, let's take a step back and just look at the awesome toolbox we've built today. You've just armed yourself with a seriously powerful and practical set of tools to handle pretty much any chemical calculation that comes your way. Here it is, the whole shebang, all in one place. These 4 conversions are the heart of your new toolbox. You can now confidently jump between mass, moles, and the number of particles for any substance. This right here is the language of chemistry, and you're getting fluent fast. And look, this isn't just about passing a test, right? This is the key that unlocks, well, everything. From creating new medicines to designing futuristic materials, it's how we understand and shape the world on the most fundamental level. So now that you can speak the language, what are you going to discover?